All right, guys, welcome to the assignment here for ECMN 223 industrial wiring. We're going to talk about a couple of things that'll help you with the final assignment. The first thing I want to get to is just in general three-wire control circuit and how you guys should try and create the paragraph or couple of good sentences at least, trying to explain how the control circuit is going to operate. Basically a sequence of operations. So you could do it one of two ways. You could either come up with your own schematic and write the sequence of operation based on that, or you can try and write a sequence of operation and then design the control circuit, whichever fancies you, essentially, whichever way you want to do it. So here we have the circuit already. Basically, I would start off by saying this control circuit is going to use three-wire control. We're going to do so with a normally closed stop button and a normally open start button, both in which are momentary push buttons. Once the start button is pressed, the motor starter's coil will be energized. Once the start button is released, the holding contact on rung number 2 is in place to allow current to continue to flow to that motor starter's coil. Down below on rungs 3 and 4, we have a normally open contact that's being controlled by the M coil. That's going to turn a red light on when the motor is running. And we have a normally closed M contact on rung number 4 that's going to allow a green light to be on when the motor's off and off when the motor's on. Keep in mind that cross-referencing is important, especially as we get into the control relays and things like that. You might have 2 or 3 control relays along with the motor starter coil. So you're going to have several coils that you're energizing as control devices to turn on and off different loads or have different things happen. So please try your best to cross-reference and label everything properly. Here you can see the X1's labeled. The circuit breaker for the control circuit is in place. And then I don't really need to see a power circuit, although it would be nice, but at least a control transformer indicating your voltage and your X1 and X2. Next, we went over running and jogging. So again, the jogging function is achieved by eliminating the holding contact from the circuit. So again, here I'd say I'm going to design a control circuit that will run and jog a motor. I'm going to do so using 2 momentary push buttons, one normally closed as a stop button, one normally open as a start button, and then by putting a selector switch in series with my motor's holding contact, I'll be able to basically turn on and off the holding portion of the circuit, allowing the motor to either run or jog. The second portion there, we're using that 2-circuit push button. And again, that normally closed portion of the button is in series with the holding contact. So when we push that button, and remember we called it a break before you make. So if we push that button slightly, it'll actually open up the normally closed and not quite make it to the normally open yet. Here I wanted to show this shop job again because I do like the usage of the e-stop. It is something that we're going to try and get a little bit more familiar with next semester when we use the conveyor system and things like that. E-stops are obviously very important in control circuits and in control situations. They need to be able to turn off the entire process with one human motion. So here we have the e-stop that's basically in series with the start-stop station, and that's just just basic 3-wire control. You could talk about how the e-stop is in there to kill the circuit all at once. Something that's really popular is using either an e-stop or some type of proximity sensor to a control relay as what would be known as a master control relay. So essentially, the e-stop will turn the control relay on and off. And the control relay will actually be used to switch the X1 and X2 rails with 2 normally open contacts, or you could do normally closed, or there's different ways of doing it. But essentially, if the control relay is energized, that means that the e-stop is not being used, and everything is safe, and the control circuit below will function. When you press the e-stop or activate the e-stop, it will break the X1 and X2 power rails and basically disable the remainder of the control circuit. So we like to call that either a safety relay or a master control relay. There's different terms that are used. but ultimately it is a nice way to ensure that the rest of the circuit is going to be shut off should there be an emergency situation. In this next slide, I was able to find an image of the Square D 120 volt electromechanical relays that we use in shop. And one really nice thing about these relays is one, the contacts actually have a 10 amp current rating, which is really nice. It's pretty high for a control circuit, but it's really nice. And then if you look right inside of here, what you're actually seeing is that's a symbol for normally open contact. Well, if you take this top plate off and you loosen up 1, 2, and 3 screws, you could actually take this whole top plate off, which will give you access to the coil. This is the plunger that gets pulled in when the coil is energized. And if you take this plate off, you could actually flip the control relay contacts upside down, and you'll see a yellow indicator with a normally closed contact on there, indicating that it's actually now a normally closed contact. So it's physically the same contact, but by flipping it upside down, you're actually biasing it basically to be normally closed. And we could see that in the next one where we would use it. So here's a run and jog circuit using a control relay. All right. And I don't want to say overkill, but there's things done here for certain reasons to ensure that if the motor's running, things will seal in and keep it running. So we have 2 stop buttons, stop 1, stop 2. Either one of those obviously will prevent the motor from running, but you could still jog it. Okay, so there's modifications that I like to make to this circuit in shop, where I have you guys put the stop button so that the jog button won't work as well. Unfortunately, obviously we didn't get to that, but look forward to this next semester. So here we have 2 stop buttons that are wired in series. Stop buttons always go in series, whereas if we wanted 2 starts, like MC4, that was a lot of fun, you would put it right in parallel, right? So here's our run button, and we're actually energizing the control relay. So we're turning on the coil for the control relay, which down here on rung 3, so we see that cross-reference, 3. So down here on rung 3, that normally open contact will close, energizing the motor starter coil. This CR will close, that M will close, the motor will run. Well, the only problem I see with this is, and that's why I tend to put it after stop buttons, is I could still push the jog button. Not that it will do anything, but I like to have it disabled when it's running. So you could also throw a normally closed control relay right here, and that'll eliminate that problem. So what would the condition of the light be? Obviously, it's only going to be on when the motor is doing what, all right? So we press run, okay, CR comes on, that seals in. This CR closes, that seals in. This CR right here is going to open, all right? So that means that this light will only indicate when it's actually jogging. So the CR will be de-energized, allowing this to stay closed. When the jog button is hit, or activated, it will turn on the M coil. The M coil will make this contact seal in and will allow the motor, the indicator, to jog, as it says here on the right side. All right, so just a little bit of information on that. If you're feeling risky, if you want to go for something like this for your final project or your final assignment, by all means, please do. There is no real wrong that you can do for this assignment given the circumstances. I just would like to give you guys something as some closure for this semester, so please try your best, and please email me if you have any questions. Thank you for watching.